Hey again everybody, Pre-Calc students and anybody else who's watching. Time for another online lesson today, 6-4 amplitude and period. This is one of the cornerstone lessons in this chapter because what we're going to be doing eventually is looking at equations of sines and cosines and being able to pick out some important features of them, two of which are the amplitude and the period. So when you think about amplitude, first of all, you might think of an amp like this for an electric guitar or other instruments, or some of you probably like this kind of energy drink amp. But what we mean by amplitude in trigonometry anyway is the maximum absolute value of a periodic curve measured along its vertical axis. That's kind of a mouthful of a definition for sure, but I think you'll be able to get the hang of it as we look at some more. So here's a visual of amplitude. So keep in mind amplitude is a y value. And most of the time we can look at it in regards to what the graph looks like. Keep in mind that it's measured from the midline, and oftentimes that midline will be the x-axis, but not all the time. So the amplitude is this vertical distance. Notice it's the same both positively and negatively, although amplitude is always regarded in terms of absolute value. Alright, and the other thing we want to look at before we start doing some examples here is something called the period, and that's the number of units required for the function to complete one full cycle. So from a previous lesson you may recall that we said the period of the sine function was 2 pi. That means that it takes 2 pi units for it to complete one full cycle, or one period. And of course with a sine wave, this counts for both sine and cosine, one full period would be starting at 0, getting to its maximum, back down to its minimum, and then back to where it started. So the period, the normal period for sine and cosine, as you remember, is 2 pi units. Alright, now let's actually look at a pretty important equation that we're going to be looking at from time to time here, and we're going to expand on this as we move throughout the lesson. Y equals b sine x over a. We'll be trying to get all of our equations in this form somewhat so we can pick out a couple important features. Now the amplitude in this case is this b value. That's always the amplitude. And keep in mind that we say it always has to be positive, so it'll be the absolute value of that. You might recall from my previous chapter that if I put a negative sign in front of this, it would just cause it to reflect over the x-axis. So the amplitude is usually pretty easy to pick out. Now x is the variable. Sometimes we'll see that as x, or sometimes we'll see that as the variable theta might be in place of that x sometimes too. But that's the variable that doesn't tell us anything that needs to be in there because we need a y and an x, or a y and a theta. But the other important component here is this a value. It has something to do with the period, but keep in mind that a is not the period. A is not the period. Here's a little equation to help us remember how that all fits together. The period equals 2 pi times this a value, or if we rearrange things, another way to say it would be that a would be the period divided by 2 pi. Okay, so keep that in mind. A is the period divided by 2 pi. It's interesting to note as we connect this to some prior learning that both the amplitude and period are dilations. If you remember back in an early chapter we had the big chart of transformations of functions, and notice that since the amplitude is multiplied, the period is sometimes multiplied or divided. Those will affect the graph by either stretching or shrinking. Dilations is the more mathematical word for that. Alright, so this is a very important thing to have in your notes, and especially this little item as well, that connection between the period and how it fits in this particular equation. Let's start doing a couple examples here. So first of all, we want to just try to pick out the amplitude and the period for each of these functions. Now, the first one here, fairly straightforward. The amplitude, notice that even though that's a negative number, we still say that the amplitude is 2. Amplitude is always absolute value. Now the period, we remember, has something to do with this 3. The period is not 3 though. Remember we say that the period equals 2 pi times that a value. And that a value is what's in the denominator there. So in this case, my a value is 3. So 2 pi times 3 will actually be 6 pi. 6 pi for that period. So a pretty long drawn out period there for that. All right, let's look at the next example. Is kind of trickier. The amplitude is pretty straightforward again. In this case, the amplitude will be 1/2 or 0.5. Always sitting right out there in front of the graph. Now, kind of tricky though as far as the period. Notice that we like to have that x by itself in the numerator. Here it is not. So you remember from your middle school days perhaps that multiplying by 4, as this x is being done here, multiplying by 4 is like dividing by 1/4. So I'm going to write it like that. Now that looks kind of messed up until you remember that that helps us find the period. Remember the period is 2 pi times this a value. So in this case, the period will be 2 pi times 1/4. 2 will go into 4 2 times. So the period in this case actually ends up to be pi divided by 2. Now we could verify this on your calculator by just graphing this function. You can see what the period would look like. But we'll be doing several types of problems like this where you have to pick out the amplitude and period, and maybe you have to do a little algebraic gymnastics, I'll call it here, in order to be able to pick that out correctly. You could go right to your graph, but sometimes that's a bit tricky to pick out, especially the period. So that's why this algebraic method here is pretty solid. Here, this time we're actually going to try to write an equation, sine function, that has an amplitude of 2 and a period of pi over 4. So we remember that when we write this, it's going to be in this kind of form, y equals b sine, and then we'll have this x over a. But remember, a is not the period, but we do recall that the period equals 2 pi times a, or as we recall from that other slide, if I solve this for a would equal the period divided by 2 pi. So I need to figure out that a value. So if they tell you that the period in this case, I'll change colors here for a little emphasis. So if they tell you the period is pi over 4, and I have to divide that by 2 pi to get that a value, well, again, here's a little middle school mathematics here. Dividing by 2 pi is the same as multiplying by 1 over 2 pi. Notice that the pi's will cancel out here, right? And so what I'll end up with then is 1 over 8. That's what that a value is going to equal. So if I rewrite this then, I'll go back to my orange color here. My final answer then will be y equals, amplitude is 2, so that goes right in front here, 2 sine, and then x divided by, we just figured out that that a value was 1/8 there. So I could write it like that. If I wanted to pretty this up a little bit, I could write it as 2 sine. Dividing by 1/8 should be like multiplying by 8, and I'd get that for an answer right there. All right, so kind of tricky, a little bit of gymnastics going on here as we get ready for the gymnastics season. But we'll work on these in class tomorrow too. But make sure to get them down. And here's some amped up Rice Krispie bars. I saw a recipe for this online, so I thought I'd share that with you. It has not only Rice Krispies, but it has some chocolate in them, which sometimes they do, and also some butterscotch and cinnamon in the center there. So feel free to make those or check those out. All right, thanks for watching, everybody. We'll see you guys in class.